Imagine floating hundreds of miles above Earth, watching continents drift by beneath you, with no gravity to hold you down. Now imagine it's mealtime. You can't just grab a sandwich or pour yourself a soda, because crumbs and liquid droplets would float away and clog equipment or end up in your nose. Yet astronauts still need nutritious, comforting meals that fuel their bodies and lift their spirits during some of the most stressful and extraordinary missions imaginable. Since the dawn of human spaceflight, NASA has been obsessed with one big question: how do you make food that works in space? What began as pureed meals squeezed from toothpaste-like tubes has now evolved into a surprisingly diverse menu of freeze-dried dishes, ready-to-eat entrees, and even fresh produce grown right on the International Space Station. And as humanity looks toward the Moon, Mars, and beyond, the science of space food is becoming more important and more fascinating than ever before. In the early 1960s, when John Glenn became the first American to eat in orbit, it was still unclear whether humans could even swallow food in zero gravity. He managed to squeeze applesauce and sugar tablets into his mouth, proving digestion worked just fine. But taste and texture were another story. The first generation of space food was bland, messy, and frankly unappealing. A famous incident during the Gemini 3 mission revealed just how tricky food could be in space. Astronaut John Young smuggled a corned beef sandwich onto the spacecraft as a joke. When his crewmate Gus Grissom took a bite, the bread instantly crumbled, sending dangerous floating crumbs into the air. NASA immediately banned traditional bread, later turning to tortillas as a safer substitute since they don't shed crumbs. That moment showed everyone that space food wasn't just about calories and nutrition. It was about safety, practicality, and even morale. As missions grew longer and more ambitious, NASA realized that food played a huge role in keeping astronauts healthy and mentally strong. A meal could remind astronauts of home, boost team morale, and offer comfort during long months away from family. At the Space Food Systems Laboratory in Houston, scientists developed strict requirements. Meals had to be lightweight, compact, safe for microgravity, resistant to spoilage, and nutritionally balanced for the unique stresses of space travel. Some of these foods can last as long as 5 years without refrigeration, a necessity when planning for missions far beyond Earth's orbit. But NASA also recognized that astronauts deserved more than survival rations. Today, crews aboard the International Space Station receive resupply shipments that often include fresh fruit, vegetables, and even ice cream, offering rare tastes of Earth in an otherwise sterile environment. To push things even further, NASA began experimenting with actually growing food in orbit. The Veggie Project on the ISS has already produced red romaine lettuce, radishes, mustard greens, and chili peppers under microgravity conditions. Astronauts describe the thrill of eating something they harvested themselves hundreds of miles from Earth. This breakthrough is vital for future missions to Mars, where resupply missions won't be possible and astronauts will need to grow their own food for years at a time. But before food makes it to orbit, it has to undergo a rigorous transformation on Earth, where scientists use specialized processing methods to balance nutrition, safety, and taste. One of the most important techniques is freeze-drying, which removes nearly all the water from a food while preserving its shape and flavor. First, the food is frozen solid. Then, in a vacuum chamber, the ice sublimates directly into vapor and disappears, leaving behind a light, crisp version of the original. Add water later and it springs back to life. Other meals require a process called thermostabilization or heat treatment. These foods, like stews, soups, and casseroles, are cooked, sealed in flexible pouches, and heated to kill harmful bacteria while locking in flavor and extending shelf life. Some foods, like nuts, granola bars, or dried fruit, don't need much processing at all. But even those have to be repackaged in NASA-approved materials to ensure safety aboard a spacecraft. Drinks are another challenge in microgravity. Pouring orange juice or coffee would result in floating blobs that could short-circuit electronics. Instead, beverages are dehydrated into powders, packed into special pouches, and reconstituted with water in orbit. Each pouch has a built-in straw with a clamp, so astronauts can sip safely without spills. Even condiments had to be reinvented. Salt and pepper can't be sprinkled in space because grains would float away. Instead, they're provided as liquid solutions, salt dissolved in water, pepper suspended in oil. Astronauts squeeze droplets onto their food before mixing them in. Packaging is just as important as the food itself. Every pouch is made of materials that won't burn, release toxins, or damage delicate spacecraft systems. Velcro patches and magnets are added so food can be anchored to trays, walls, or equipment during mealtime. Utensils are designed to clip into place, preventing them from drifting off mid-bite. Each package carries a barcode which astronauts scan to log what they've eaten, helping NASA monitor nutrition and calorie intake. Meals are carefully organized, labeled, and loaded into resupply ships, where every inch of space is maximized to ensure astronauts have enough food for weeks or months in orbit. When it's time to eat, astronauts have two main options. Freeze-dried meals must first be rehydrated using a specialized station. A needle is inserted into the pouch's port, hot or cold water is injected, and the package is sealed and left to sit. In just a few minutes, what looked like a brick of powder transforms into pasta, rice, or even scrambled eggs. Heat-treated foods, on the other hand, are simply warmed in a small oven-like food warmer that uses contact heat instead of open flames, since fire is far too dangerous in space. Astronauts cut the pouches open and eat directly from them with spoons or forks. Drinks are sipped from their sealed straws and condiments squeezed on as needed. Once the meal is over, every scrap of packaging is sealed and stored until it can be returned to Earth or safely disposed of. While much of the system is built for function, NASA never forgets that taste matters. Before any meal makes it into space, food scientists and sensory experts test it for flavor, texture, and overall appeal. NASA has even created a dedicated tasting panel to evaluate hundreds of recipes. Meals must meet strict dietary guidelines that emphasize protein, vitamins, and minerals needed to offset the effects of microgravity. Calcium and vitamin D, for example, are critical to counter bone density loss, while antioxidants help fight radiation exposure. Every bite is carefully analyzed not only for flavor but also for its ability to sustain astronauts physically and mentally during long missions. Shelf life is another crucial factor. Space food has to remain safe and nutritious for years, especially for deep space missions. To ensure this, scientists simulate long storage conditions, testing foods for changes in flavor, texture, and nutrient stability. Some items can last more than half a decade without refrigeration. Once approved, they're stored in controlled environments until they're ready to launch. Backup supplies are also prepared in case missions run longer than expected or resupply flights face delays. Despite all the scientific precision, NASA still makes room for a human touch. Astronauts are allowed to request a few personal favorites, whether that's hot sauce, barbecue sauce, or a treasured comfort food from back home. These small luxuries can make a big difference in morale, turning a sterile routine into a moment of joy. Imagine living in one of the driest deserts on Earth, where summer temperatures can soar above 110 degrees and rainfall is so scarce that it barely reaches 4 inches a year. Now picture building a futuristic city there, complete with skyscrapers, fountains, green parks, and even artificial islands. How do you keep such a city alive? How do you ensure that millions of people have enough water in an environment where nature gives you almost none? This isn't a scene from a science fiction novel, it's the reality of Dubai. And to solve this massive challenge, the city has turned to one of the most fascinating technologies of our time, making rain. Yes, you read that right. Scientists in Dubai have found ways to create rain out of thin air, and today you're going to see exactly how they do it. But stay with me because this story isn't just about Dubai. It's about a decades-long scientific pursuit that started in the United States, spread across the world, and is shaping the future of how we think about water, climate, and survival. The concept of artificially making rain, called cloud seeding, wasn't invented recently. It actually began back in 1946 when an American chemist named Vincent Schaefer, working at General Electric, discovered that dropping dry ice into a cloud could trigger snow. This sparked a wave of experiments, and soon silver iodide became the material of choice for encouraging rainfall. By the 1950s, governments across the globe were exploring how to use cloud seeding to reduce droughts and protect crops from hailstorms. In fact, during the Vietnam War, the U.S. even attempted to use cloud seeding as a strategic tool by trying to extend monsoon rains. It sounds like something out of a weather control conspiracy, but it was very real. Over the decades, more than 50 countries, from China to Australia, developed their own programs, and today, as climate change makes droughts more severe, the technology has found new urgency. Dubai's National Center for Meteorology is one of the most advanced hubs in this field. Every day, meteorologists closely monitor the skies for the right kind of clouds. Not every fluffy white cloud can be turned into rain. They look specifically for cumulus clouds with enough vertical depth and, more importantly, enough supercooled droplets. These tiny droplets are water particles that remain liquid even below freezing. Without them, cloud seeding won't work. When scientists spot a promising cloud, the clock starts ticking. Clouds move, shift, and dissipate quickly, so decisions have to be made in minutes. That's when the meteorologists radio train pilots stationed at nearby airports. These pilots are ready around the clock, because timing is absolutely critical. The aircraft they fly are typically lightweight twin-engine Beechcraft King airplanes. Don't let their size fool you. These machines are specially modified for a job that requires flying directly into unstable weather. Under the wings, racks are loaded with flares packed with a mixture of salts, including potassium chloride, sodium chloride, and magnesium. Once ignited, these flares release a fine mist of particles into the clouds. These particles act as condensation nuclei, giving water droplets a surface to cling to. As more and more droplets stick together, they become heavier until they finally fall as rain. It's like giving clouds a gentle push to do what they were already on the verge of doing. Safety, however, is non-negotiable. Before every mission, both pilots and engineers meticulously inspect the aircraft and the flares. Cloud seeding often means flying into turbulent, storm-like conditions, and no risks can be taken. Once cleared, the pilots take off and climb to altitudes between 5,000 and 20,000 feet, guided closely by meteorologists tracking the cloud from the ground using radar. When they reach the right zone, the flares are ignited remotely, and the transformation begins. Inside the cloud, fine particles spread like invisible dust, encouraging droplets to collide, merge, and eventually fall to the desert below as life-giving rain. The results are striking. Studies have shown that cloud seeding can increase rainfall by 15 to 30%. For a city like Dubai, where desalination plants currently provide the bulk of drinking water, even a small increase in natural rainfall can ease the immense financial and environmental costs of turning seawater into freshwater. But scientists don't stop at just making it rain. They continue to study where that rainfall goes, how much infiltrates underground aquifers, how much evaporates, and how it affects soil moisture and local ecosystems. This constant cycle of monitoring and testing ensures that cloud seeding becomes not just a quick fix, but a sustainable part of water management. Dubai is also investing heavily in the next generation of weather modification. One of the most exciting frontiers is drone-based seeding. Instead of using flares, drones fly into clouds and release tiny electrical charges. These charges encourage droplets to cluster without the need for chemicals, making the process cleaner and potentially more precise. If this technology proves successful, it could change how countries around the world tackle drought. Already, regions like Texas are studying whether cloud seeding could help alleviate their water shortages. Still, experts caution that cloud seeding alone isn't a silver bullet. It must work alongside conservation, better irrigation, and improved reservoir management. Water scarcity is a complex challenge, and no single solution will solve it all. But this story of innovation doesn't end in the skies. Let's shift from clouds to something far closer to everyday life. Something you probably use for hours every single day without even thinking about it: headphones. Believe it or not, the journey of how your favorite pair of headphones are made is just as fascinating as creating rain. At first glance, they might look like simple gadgets, plastic shells with some wires and padding. But inside, they're a marvel of acoustic engineering, electronics, and craftsmanship. More than 500 million pairs of headphones are sold every year, with Apple, Sony, and Bose leading the industry. They've become an extension of how we live, work, and escape. Whether it's drowning out noise on a flight, getting lost in your favorite playlist, or taking a Zoom call, headphones have transformed from a niche invention into a cultural necessity. The story of headphones goes back further than you might think. In 1910, Nathaniel Baldwin, an engineer working in his kitchen, built the first pair for the U.S. Navy. They were clunky, wired, and purely for military communication. Decades later, in 1958, John C. Koss created the first stereo headphones designed for music lovers, forever changing the way we listen. Fast forward to the 1980s and 1990s, and the Sony Walkman and Apple iPod turned compact headphones and earbuds into everyday accessories. Today, wireless technology, active noise cancellation, and even AI-driven sound optimization have made headphones smarter than ever. From bulky headsets of the past to sleek AirPods and high-end Sony WH-1000XM5S, each generation reflects leaps in science and design. So how exactly are they made? It all begins with the driver, the beating heart of every headphone. The driver converts electrical signals into the sound waves you hear. To build it, manufacturers use ultra-thin diaphragms, sometimes made from advanced materials like graphene or beryllium, molded for perfect flexibility. A delicate copper or aluminum wire, thinner than a human hair, is wound into a voice coil. Paired with a powerful neodymium magnet, this tiny assembly is capable of reproducing sound with incredible accuracy. Each driver is then tested with lasers and microphones to measure frequency response. Precision here is key, Even the smallest defect could distort the sound you hear. Next comes the housing, the outer shell that holds everything together. It's more than just looks. Whether it's ABS plastic, aluminum alloy, or even carbon fiber, the housing must be strong enough to withstand daily wear while minimizing unwanted vibrations that could affect sound quality. Once molded, it's polished and coated with a scratch-resistant layer. Then come the ear pads and headbands. Comfort matters as much as sound, so memory foam, soft leather, or high-tech fabrics are used to ensure long listening sessions don't cause fatigue. The driver is securely mounted inside the housing with industrial-grade adhesives, completing the core structure. But the process doesn't stop there. Each headphone undergoes sound calibration. Specialized microphones test how the driver performs across frequencies, and if the model supports active noise cancellation, algorithms are programmed to cancel out unwanted sounds by producing phase-reverse sound waves. Premium models even use AI to adapt sound profiles automatically based on your environment. To guarantee reliability, the headphones are subjected to a burn-in process, continuous playback for 24 to 48 hours, to reveal any weaknesses. Durability tests follow. Headbands are bent thousands of times, cables are pulled with heavy force, and wireless models are tested for Bluetooth stability at varying temperatures and humidity levels. Only after surviving this rigorous gauntlet are headphones packaged in pristine conditions and shipped out to stores. The result is something we often take for granted: the ability to carry an entire concert hall, podcast studio, or movie theater in the palm of our hand. Think about that for a moment. The same level of engineering precision that lets Dubai create rain in the desert is also what lets you stream your favorite song in crystal clarity. Both stories, whether in the skies or in your ears, are testaments to how far human innovation can go when we refuse to accept limitations. So next time you pop in your earbuds or adjust your noise-canceling headphones on a flight, remember that you're wearing over a century of design, science, and creativity. And when you hear about Dubai making rain, don't just think of it as a desert experiment. Think of it as humanity's constant drive to solve impossible problems. From the clouds above to the sound in your headphones, innovation surrounds us in ways we rarely notice but can no longer live without.